In this corner, weighing in at 90 volts DC, it comes with a treadmill, requires an auxiliary controller, and is some people's first choice. I give you the MC2100! And in this corner, weighing in at 110 volts AC, it's accused of putting out dirty power, ruining treadmill motors, and is the villain everyone loves to hate. I give you the SCR! Greetings, fellow DIYer, and welcome to my video. I have a couple videos on my channel talking about power supplies for treadmill motors so that you can use them in shop tools. The first one is building a quality power supply using an SCR Voltage controller. And the second one goes over the different boards that come in treadmills. Because of these videos, I've received a lot of questions wondering which one is better, which one should I be using. So I've created this video to compare the best of the boards, the MC2100, to a power supply made with an SCR Voltage controller. Keep in mind, this video just hits the highlights, and if you want a lot more detail on how to correctly set up either an MC2100 type board or an SCR Voltage controller, you really need to check out my webpage on setting up variable speed shop tools. So let me start by conceding. A high-end pulse width modulator is going to outperform both of these units. It is designed to power a DC motor and is a far superior solution. With that said, a good quality pulse width modulator with the amperage and voltage required to power a treadmill motor is going to be $200 to $300. And if you're going to spend that kind of money, you might as well get a VFD and run an AC motor. This is the budget option. This is for the home hobbyist that is wanting to improve their shop tools, and they're wanting to do it as inexpensively as possible. With that in mind, these are the budget-friendly options because, in theory, this comes with a treadmill, and you spend between $10 and $15 for this, and this can be had for about 20 bucks, and then you just need the rectifier, and it's another $10 to $15. So here we have the MC2100. Very common in a lot of treadmills and is fairly easy to use if you're trying to set up a treadmill motor on your variable speed shop tools. One thing that is required to make this work is a pulse width modulator. This generates the signal that is used to drive this board. As the signal here increases, it tells the board to produce more power for the motor. It has a nice big capacitor, which is great for helping keep smooth, consistent power. Another nice feature is this right here. This is a connection for a fusible link. So if your motor has blue wires, this is a great place to attach the blue wires, or you can put a circuit breaker there so that if there's an issue, it trips. Right here, we have the bridge rectifier, and this is what is converting AC into DC. So if you're going to be plugging this into the wall and using it to power your DC motor, you are required to use a rectifier. You have to be able to switch from AC to DC. So the comments that I've seen that these units don't put out true DC power, it is what it is. Unless you're going to run it off of a battery, you're going to have to use a bridge rectifier. So here we have the villain that everybody loves to hate, the SCR Voltage controller. The first thing I've heard the haters say when it comes to the SCR Voltage controller is all that is an AC light dimmer, and it has no business running a motor. And then they talk about how using an SCR Voltage controller like this on something like an AC motor will cause that motor to burn out. Well, they're absolutely correct. If you put this on an AC motor, it will slow the motor down, but it's not going to run very well, and the life of the motor will be significantly shortened. But that does not mean that if this is hard on an AC motor, that when set up correctly, it's automatically going to be hard on a DC motor. AC motors and DC motors, they're totally different. They work totally different, and they follow different sets of rules. Now, all this talk about this being AC, and a treadmill motor runs on DC. So how are we making this conversion? That's this right here. This is a bridge rectifier. This is basically 4 diodes wired together that shunt all of the positive current into one leg and all of the negative comes back in the other leg. And this is what allows us to use something like this to drive our DC motor. So what are some advantages to this? Well, the first one is that it's super easy to hook up. You got power coming in from the wall, and from there it goes into your bridge rectifier, and then from there it can go into your DC motor. That is, of course, if you're not using some other devices to help eliminate power spikes and stuff, but we'll get back to that. So hookup, fairly simple. The next thing that's really nice about it is it's controlled by a potentiometer. Now, this unit right here came with a 500K potentiometer, so that's 500 kiloohms, and that was way too big. When I turned the knob, I had to turn it about halfway before the motor would come on. Now, a simple solution for setting this, and I go over this in my SCR Voltage controller video, is to use a smaller potentiometer, and you can use a meter to figure out exactly what size you need. But one thing that makes this even better is if you use 2 potentiometers, one that is significantly smaller than the other, then you can have a fine control and a coarse control. And this is how I have it set up on my lathe. So in the case of my lathe, I needed a total of 140 kiloohm potentiometer. So I put in a 20 kiloohm potentiometer and a 120 kiloohm potentiometer, and then I wired them in series. So the advantage to that is with the 20 kiloohm, an entire turn of the knob creates 20 kiloohms of resistance. Whereas the 120, the entire turn of the knob is 120 kiloohms. That means that the smaller one is 6 times more fine. In other words, if I turn it 1/4 of a turn, I will get 1/6 of the speed change that I would get from 1/4 of a turn using the bigger potentiometer. This has been fantastic on the lathe as it has helped me to dial in speeds and feeds, especially when I'm threading. So why is everybody a hater? Why do so many people dislike the SCR Voltage controller? Well, the first reason is not all SCR Voltage controllers are created equally. There are some cheap ones out there, and the cheaper the power supply, the dirtier the power. Now, the nice thing about this one is this is about the best unit you can get, and the power that's coming out of it is fairly clean to begin with. So here's some basic performance with the SCR Voltage controller. Use an RPM meter. Runs at about 650, give or take. And crank it up. Now, one thing to note, if you speed it up quickly, it is a little harder on the brushes and the inside of the motor. So if I go from the speed it's at now, you heard it making a little staticky sound when it first started to speed up. That is hard on the brushes. But it is nice to have the option to go up to a higher speed quickly. You can hear we've now slowed down to the speed that the SCR is set at, and it's running beautifully. It's not a lot of noise, it's not producing a lot of heat, and it's working very well. And now the MC2100. Slowest speed on this. So we're about 200 RPM slower. So that could be an advantage of the MC2100 over the SCR. But here's something. I turn it up. I have to go a ways before speed begins to increase. Right around 20% is where speed kicks up, and it kicks up quite a bit, almost double. So yes, it has that slower speed, but then it just kind of jumps up to about 800. Then notice how it takes it a second to get to that speed. Now this is one thing that I noticed. So here we are at roughly 1700 RPMs, a little more. If I go one click, we've gone up over 100 RPMs. So there's no way to get between the 1700 RPM and the 1800 RPM that I'm at now. Here we are at 75% duty cycle, and we are right around the same speed I was at with the SCR Voltage controller. And we've leveled out. Now, one thing to note, if I cut the power here and turn it back on, the motor's not going to come on because of soft start. I'll have to turn it off here and then back on here. But I can just do all the controls here and then have this be the master power. So takes it a minute to come back up, but it will come back up to speed. So let's compare these two units. What do? Well, on a very fundamental level, they do the exact same thing. They both have a heavy-duty switching transistor in them. In this case, it's underneath the heatsink here, and on this one, it is right here, that switches on and off very rapidly to reduce the voltage. Well, if they do the same thing, why are we even debating which one is better? It's not what they do, it's how they do it. This one switches on and off and cuts down AC current. This one, the AC current becomes DC current, and then it switches off and on rapidly. The advantage to doing the switching on AC current is that fewer components are required. You can see there's not a lot of components right here compared to all of this. Now, mind you, some of this is for other parts of the treadmill, but most of this is the power supply. So by switching on and off on the AC side, we have less components, less things to go wrong. The second thing to note between how the AC one and the DC one works is DC inherently produces more heat. And electronics, they don't like heat. So when you're dealing with DC current, there's going to be more heat. That's why the heatsink here is the entire board. You know, all these components are tied into this board. This resistor gets quite hot. You've got the switching transistors. You've got the bridge rectifier. All of that produces a lot of heat. On the AC side, things run cooler. Now, don't get me wrong. Heat is also produced. That's why we have a heatsink, and that's why we have a cooling fan. But as a whole, doing the switching on the AC side runs cooler. So we have fewer components. It's going to run cooler. That ultimately means that this is more robust than this. This has a tendency to not be able to handle as much abuse as this does. Case in point, if you turn this on, you use your pulse width generator to set a speed, and let's say it's a fairly fast speed. You're near the max of the motor. Then you push the button to turn it off, you let it come to a complete stop, and you turn it back on again. Depending on how much amperage that motor draws, there's a good chance you're going to burn this board out. I have actually done that. You know, if you're at 75% of max, it's probably not going to happen. But if you have it set at full speed, you're going to have problems. With the SCR voltage controller, that's not an issue. I can crank it up to max, flip the switch, turn the motor on, it'll come up to speed, it'll run there, no issues. I can turn it off, turn it back on, and we don't have that problem. So this is a little more durable, it's a little more robust than this. So if this is cooler, and this is more robust, has fewer components, why is this even in the running? Well, that's pretty simple. The power that comes out of this has a lot of power spikes. It's not as clean and consistent as it should be, and using dirty power will shorten the life of your motor. Now, I've done a bunch of testing, and the power coming out of this is a whole lot cleaner than the power coming out of the other SCR voltage controllers that are available. A lot of the power supplies that people are building and selling on eBay have the cheaper SCR voltage controller in it, and they don't work very well. So if this produces dirty power, and dirty power shortens the life of treadmill motors, why is this in the running? Well, that's simple. Because we can clean this power and get it to perform about the same as this. And all we have to do that is add a couple of ferrite chokes. This is an AC ferrite choke. It goes between the output of this and the AC inputs on the bridge rectifier, and it helps eliminate a lot of the power spikes. Then coming out of the bridge rectifier, we use this right here. This is a DC ferrite choke. It goes on the positive terminal, and it eliminates most of the remaining spikes. You're going to get spikes on both a unit like this and this, but you're going to get it to the point where it functions well. So one major advantage of this over this is size and mounting. So I've taken the cover off of this, and if you look inside, you have a small board right here that's attached to a heatsink. If I remove that screw and I remove the potentiometer from this box, this board can be taken out. And that's what I did on my power supplies. I removed it from this unit and installed it into my own box. Then the potentiometer can go on your controls for your shop tool, and then you just run a longer wire between the potentiometer and this. Now, in the case of this is a lot bigger unit to have to try and mount somewhere. It's going to take a bigger enclosure. And then when we get to the actual controls, this is also bigger. So that makes mounting it up a little more cumbersome and a little harder to do. Another thing to look at is replacement cost. Now, if you've scrapped a bunch of treadmills, you may have 3 or 4 of these laying around. And replacing it is a piece of cake. But if you've only gotten one treadmill and you're running this and this fails, suddenly your shop tool is no longer working. And to replace this by itself, to buy it used off eBay, I've seen them go as low as about $50. A lot of them are more expensive than that. As we talked about before, the price of this is pretty inexpensive. This is my extra SCR. So I have this sitting in a box so that if I end up messing up one of my power supplies, all I have to do is grab this off the shelf, install it, and my shop tool is up and running, and I don't have a lot of money tied up sitting on the shelf. So this produces nice clean power, but it gets hot. There's more components to break. This produces less clean power, but the power can be cleaned up. So ultimately, which one is better? And the answer is they're both very good options. If you get a treadmill that has one of these, you pick this up, what's the point in investing in this? If your treadmill doesn't come with this, picking up this and go in that direction, that is a simple solution that also works well. Ultimately, I like this better than this. And I have one of these on all three of my shop tools that are being run by treadmill motors. Now, why do I like this better than this? The simple answer is this is a pickup truck and this is a Cadillac. As you saw when I was showing the bench test, this accelerates very slowly. Great for motor life, great for walking on a treadmill, but a little less convenient for shop tools. This accelerates very quickly. I turn the dial and it goes right up to the speed that I want it to. So the Cadillac is a little smoother, it rides a little better, but it's not quite as user-friendly. The pickup truck, very utilitarian. You can throw all kinds of stuff in the back of the truck and drive the truck, and it's a little more conducive to a shop environment. That analogy even goes with the fact that this is more robust than this. So that is why I'm a fan of this. The other issue, and as we saw in the bench test, this I can fine tune. I mean, if I have the coarse and the fine like I have on my lathe, I can go 1 or 2 RPM adjustments. With this, one click is anywhere between 50 and 150 RPM increase. And that may not be an issue, but I really like the fine adjustment that I have using one of these. So who's the winner? Who wins the match? It's a draw. They really both are good units. They are very functional. They're both good options. And you just have to decide which one is going to be better for your application.
If you like what you've seen, please click like. If you'd like to see more, please subscribe. Thanks for watching.